Today's lesson is on solving one-step equations. We're going to start out nice and easy with just one step because there are a few rules that are different than equations that we need to kind of master before we get into more complicated ones. But just remember, a quick review, knowing what all the symbols represent. They're greater than, less than, greater than or equal to, or less than or equal to. So here is our first example. Treat it just like we would solve an equation. I draw my line at my inequality and I want to get the variable by itself. So to get rid of 18, I'm going to subtract 18 on both sides. So I'm left with x on the right, this greater than sign, and then 13 minus 18 is -5. Now, one thing, and it's to help us graph, you always want the variable on the left side. So I'm going to flip this entire inequality so that x is on the left, -5 over here, which means my inequality sign also has to flip. So my answer is x is less than -5. Now let's just graph this on a basic number line. We've got 0 in the middle, and then we can just mark we have -5 and +5. So now, because this is a less than, anytime you have less than or you have greater than, you have an open circle. But if you have less than or equal to, greater than or equal to, it's a closed circle. So in this example, we have an open circle and it's at -5, and we're saying all numbers less than -5. So all numbers smaller, so we just have to shade to the left. Here's our next example, same thing. Draw my line, I want to get x by itself, so I have to do the inverse operation of -3/4, so I'm going to add 3/4 on both sides. So here I want to add the two fractions together, 1/3 plus 3/4, and then I rewrote them with common denominators, so that leaves me with x is greater than or equal to 13/12, which is the same thing as x is greater than or equal to 1 and 1/12. Now let's graph that. So here's my number line. 0 in the middle, and then whatever your solution is, I always write that number and then its opposite on the other side. This time at a positive 13/12, because of the or equal to line, we have a closed in dot, because we're including that as our solution. And then x is greater than or equal to, so we want to look at all numbers that are bigger than 13/12. In this example, it's a little tricky because we have this addition sign, and you always think, well, opposite of addition is subtraction. But we have a negative number. So we want to think, how do you want to do a negative? Well, you would add it. So we're going to add 1.4 to both sides. X is less than or equal to 3.7. Now let's graph it. At a positive 3.7, we have a closed circle, and this says that x is less than or equal to, so we want to look at all numbers less than, so we shade to the left. So we just did 3 examples using addition and subtraction. Now we're going to move on to multiplication and division. And there's a special rule that comes up when you have multiplication and division, and that is when you multiply or divide by a negative number, you have to flip the inequality side the other direction. So in this case, let's solve it like we would an equation. We would have to divide both sides by -7. Well, as you can see, we are dividing both sides by a negative. So when I write my answer, I have x, and then I have to flip the sign, so instead of less than or equal to, it's greater than or equal to. And 147 divided by negative 7 is negative 21. So now let's quickly graph that solution. So our answer is at negative 21, and it's once again a closed circle, and it's all numbers that are greater than negative 21. So we're going to shade all numbers larger to the right. Alright, next example. This one is a little tricky. Students often make mistakes on a problem similar to this. Well, when we want to solve it, we know that we have to divide by 60. And students will see this negative sign and say, oh my gosh, we're dividing and there's a negative, we have to flip the sign. But that is wrong, because you want to look at what number you're dividing by. We're dividing by a positive, so in this case, our sign stays the same. X is greater than a negative, and now we have to reduce 8 over 60, which is negative 2 over 15. And this time we have an open circle, and all numbers greater than negative 2/15, so we shade to the right. Here's our last example together, and then I want you to try 3 on your own. So in this one, we have multiplication by a fraction, so to undo that, we multiply both sides by the reciprocal. The reciprocal of negative 3/4 is negative 4/3. So on the right side, these cancel, and now, because we multiplied both sides by a negative here and here, we have to flip the sign. So instead of less than or equal to, it is now greater than or equal to. My x is on the right still, and now here I have to simplify 12 times negative 4/3. If I cross simplify, 12 divided by 3 is 4, and 4 times negative 4 is negative 16. So there's my solution. However, I need to rewrite it so the variable is back on the left. So x is on the left, negative 16 on the right, and now I have to do another flip. So x is less than or equal to negative 16. So we had to do a double flip. We had to flip it because we multiplied by a negative, and then to get the variable on the left side. Now let's graph it. At negative 16 we have a closed circle, and all numbers less than negative 16, so we shade to the left. Here are 3 examples I want you to write down and try on your own. Don't worry about graphing them, just see if you can solve them and follow the rules. So pause the video and try them on your own, and then check your answer. Here are the answers. I just want to make sure to point out that in the second example, the sign stays the same because you are multiplying by a positive 4. So even though you have a negative here, the number that you're multiplying by is positive. So the sign stayed the same. But in this last example, you would have to multiply by the reciprocal here, which is a negative, which means we had to flip the sign here. So 2 important things just to always remember is your final answer. Always put your variable on the left. And then this is the big one of today's lesson, is you flip the sign when you multiply or divide by a negative. Okay, 2 story problems, and we will be done with this lesson. So, just like equations, not only do I want an answer, I want you to write an inequality to represent the situation. So let's read this. Joan has started a physical fitness program. One of her goals is to be able to run at least 5 miles without stopping. She can now run 3.5 miles without stopping. How many more miles must she run nonstop to achieve her goal? So, she can currently run 3.5 miles. And we want to know how many more miles does she have to add to that to make her goal? Well, we want to go look back at, it says at least. So at the minimum, 5 miles. So she will not be happy if she runs less than 5 miles. She wants to run more than 5 miles, but she'd also be happy if it was exactly 5 miles. So here's the inequality to represent the situation, and now we solve it by just subtracting 3.5 on both sides. So x is greater than or equal to 1.5 miles. She'll be happy if she runs exactly 1.5 more miles or anything more than that. Alright, last example. You need to buy stamps to mail some letters. The stamps cost 34 cents each. What is the maximum number of stamps that you can buy with $3.84? So, let's see. If each stamp costs 34 cents, so it's 34 cents per stamp. And we're going to spend $3.84. So now we have to think about what will our inequality be to represent this situation. Because we're limited on how many stamps we can buy because of the amount of money, it's going to be less than or equal to. There's a maximum amount we can get to, so that maximum amount or anything less than it. So now we need to divide 3.84 divided by 0.34. So when you divide, you get about 11.3. Well, you can't buy part of a stamp, so really a better representation of the situation would be the number of stamps you can buy. You can buy 11 stamps or anything less than 11 stamps. So there's your solution.